All right, pre-calculus, we're in section 3.5. We're going to be talking about operations on functions. The objective for the next couple of videos will be we're going to be able to form sum, difference, product, and quotient functions and be able to find their domains. All right. So on this video, we are going to talk about the sum and difference of functions. In other words, we're going to add and subtract. Okay. Here are the definitions for the sum and function notation. Here I'm taking two functions, the function of f and the function of g. I'm funking of x. Then, which is the same thing as saying f of x plus g of x. Right. The difference and subtraction. Right. Those are the definitions in terms of function notation of the sum and difference. All right, for example 1, we are going to take, let's say, first of all, you have to be given two functions, of course. Okay, so I'm giving two functions. Now I want to apply this. So that means I take the function of f, which is 3x squared plus x, plus the function of g. Right? Since I'm adding, I can go ahead and drop the signs and combine my terms. In this case, I get 3x squared plus 5x minus 2. So this is a new function. Right? So when you use operations on functions, whether add or subtract, the end result is a whole new function. Right? And after each time, you're going to be asked to find the domain. Well, the domain on this one is all reals, because there's no fractions with variables in the denominator, and there's no radicals. There's no variables inside radicals. All right, so domain is all reals. In interval notation, they'll be written like this. All right, so you need to be able to write these in either notation. All right, let's do this difference. Let's do f minus g of x. Well, take the function of f, which is 3x squared plus x, minus the function of g, 4x minus 2. You notice here I got to distribute the negative and then combine like terms. And here's a new function, and it's different from the previous one. All right? So the domain for this new function is the same thing, still all reals, or in interval notation, negative infinity to infinity. All right, let's do another example. Let's make this a little bit more interesting. All right, so let's do, let's say f of x is equal to the square root of 9 minus x squared. G of x is equal to x minus 2. And we want the square root of that as well. All right. Well, if you notice here, I got radicals, and inside the radicals there are variables. So I know when I add, if I add these functions together, so my new functions that I will be producing will have radicals in them, plus my domain is going to have restrictions. Right? That's just giving you a heads up on that. So let's go ahead and let's just do f minus g of x. Right? So take function of f, so it'll be that minus function of g is that. And I'm done. There's my new function. I cannot distribute the negative because this is a radical, not parentheses. Right? So therefore I can't combine these because they're inside the radicals, they're not the same. So this is your new function. Now the fun part is figuring out what the domain, all right, we got two domains here we have to deal with. All right, so we'll call this part 1, and we'll call this part 2, and let's find the domains for each of those parts. All right, so for part 1, we have the square root of 9 minus x squared. Well, since it's a radical, that means the inside has to be greater than or equal to 0. But before we go any further, we have to look what's inside, what kind of equation it's in. This one is a quadratic. All right. Since it's a quadratic, we have to do it a little bit differently than if it was a linear. All right. So first thing we do, we take 9 minus x squared, we set it equal to 0, or not equal to 0. It doesn't matter. Let's see, here we solve, we end up getting x is equal to plus and minus, brain fart, there it goes, 3. All right, so I draw a number line, here's -3, 3. I have to test to find out, there's 3 sections here, which sections will make this statement true? Or I should say make this statement true. 9 minus x squared is greater than or equal to 0. So I'm going to pick the test point 0. If I plug 0 in, I get 9. Is 9 greater than or equal to 0? Yes, that's true. So that means everything between the two is correct. That will be my domain for this part, which in this case it will be -3 to 3. And let's look at part 2. Another another square root, so that means the inside has to be greater than or equal to 0 again. So therefore, now if you notice here, this is linear. So I don't have to do all this extra work. I can just go ahead and do x minus 2 greater than or equal to 0 and go ahead and just solve for x. Okay? So there is the domain for that part. Now, since both of these are in the same function, I have to combine these two to find out both parts have to be true. All right, so I'm going to take this number line. I got -3 to 3. All right, this is from part 1. Part 2 tells me that x is equal to 2. Anything greater than that works as well. So my question is this: what part, or what can we say that will make both of these true at the same time? We want to make both parts true at the same time. Well, this is right here. This is where they overlap. So this is where they overlap. That will be my answer. So it's bracket 2, comma, bracket. All right, that's one way to write the domain. All right, that's an interval notation. The other way is I can say x is less than or equal to 3 but greater than or equal to 2. All right, so there's 2 ways of stating that. Now, if I add these 2 functions, this just becomes a plus, but my domain will still end up being the same. All right, so that's how we find the domain for that.